Let's talk about how we solve radical equations that are in the form x raised to the m over n equals k. Basically, we're going to be solving equations whose exponent is a fraction. That's what we mean by rational exponents, fractional exponents. The key to this is to get rid of the fractional exponent, you're going to raise both sides of the equation to the reciprocal power. And we're going to have to be careful because when we take the square root of numbers, remember that I get plus minus. So that's going to be important. And this is what the screenshot from your textbooks is telling us. Let's look at number 32. I have x raised to the 3 halves. So what I'm going to do is I'm going to raise both sides to the reciprocal exponent. So I'm going to raise both sides of the equation to 2/3. This works because when I multiply 3 halves times 2/3, all that cancels out and I get x to the first. But how do I take 27 to the 2/3 and simplify it? There's actually two ways that I could do that. The denominator tells me the root, and the exponent, or the numerator, tells me the power that I'm going to use. So in this particular problem, this is the easiest way to do that because I know that the cube root of 27 is a perfect cube. What is the cube root of 27? 3. And then what is 3 squared? My answer is 9. And if you check that, because we need to check all proposed solutions, we have x to the 3 halves equals 27. X is 9. And so I get the square root of 9. Remember, that is the root. So the square root of 9 is 3, and 3 to the 3rd is 27. So that would be correct. It doesn't matter if that base is an expression or it's an exponent. I'm still going to solve it the same way. Look at number 34. I'm going to raise both sides to the reciprocal of 3 halves, which is 2/3. These are going to cancel out and leave me just with my base, which would be x plus 5, equals 8 to the 2/3. So that means that that is the cube root of 8. And then I can square that. Again, I'm taking the cube root. When I take the cube root, I don't have to worry about the plus minus. So the cube root of 8 is 2. So 2 squared is 4. And then if I solve for x, I'm subtracting 5 from both sides, and I end up getting -1. If you check that, you're going to see that this does work. All right, let's add a couple of steps to it. This is a very similar problem. The only difference is I've got other stuff besides the variable raised to that exponent. So all I want to do here is I want to get the variable and that rational exponent by itself. So let's move 24 to the other side. I'm going to add 24. I can divide both sides by 8, and that gives me x to the 5/3 is equal to 3. So once I get the variable part, with the exponent by itself, we're going to multiply both sides, or raise both sides rather, to the reciprocal. So the reciprocal of 5/3 is the 3/5. All right, so 5/3 times 3 to the 5th, this gives me x to the 1st. And I have the 5th root of 3 to the 3rd, or we could look at it as the 5th root of 3 cubed. Well, I can take the 5th root of 3 to the 3rd, because 3 to the third is 3 times 3 times 3. If I was to take the fifth root, I would need 5 of those. So I can't do anything to simplify this. So the only thing that I can do is just to go ahead and multiply this together. And my answer is the fifth root of 3 to the third, which is 27. I can't simplify that. I can't take the fifth root of 27. I'm going to leave my answer in that reduced form. The last example is I'm going to multiply this by, this time, the reciprocal of 2/3, which is 3/2. This is where we need to be a little bit more careful. This is going to be easy. It goes down to x plus 5 to the first. But here's the tricky part. When I'm rewriting this is the first time that I'm taking the square root of 4 and then I'm cubing it. So when this is an even number and I'm taking the square root, I'm actually going to come up with 2 answers. That's plus minus. What is the square root of 4? 2. So if I cube that, I get x plus 5 equals 2 cubed, which is 8. And I also get negative 2 cubed, which is negative 8. So I'm going to set those up and I'm going to solve. I'm going to subtract 5 from both sides and I get x equals 3. And when I subtract 5 over here, I get x equals negative 13. So I would put an asterisk beside this one and just remember that when you multiply by the reciprocal and that reciprocal is even, you're going to have to take the plus minus and that's going to make you come up with 2 answers.